You step off the edge. Just for a second, imagine it. Below you is not water, not ground, not anything you have a word for. It is Jupiter, and your brain, built for cliffs and rivers and predictable falls, has no idea what is about to happen to you. You assume there is a surface down there somewhere, a place where the falling stops and the standing begins. But the real answer is far stranger. Jupiter does not have a surface at all. Not a rocky one, not an icy one, nothing your foot could ever touch. You would fall through cloud, then gas, then something that is neither gas nor liquid, for so long that the word falling starts to lose its meaning. The first thing you would notice is the cold. Jupiter's cloud tops sit around minus 145 degrees Celsius. Your body, still warm from Earth, would start losing heat almost instantly. But you would not have long to think about the cold because you are already picking up speed. Jupiter's gravity is 2.5 times stronger than Earth's. You would fall faster here than you ever have in your life. Faster than skydiving. Faster than anything your inner ear has ever been trained to interpret. Your ears, in fact, would be among the first things to fail you. On Earth, your vestibular system uses tiny fluid-filled canals to tell your brain which way is up. It evolved over millions of years to handle one kind of gravity, one kind of falling, one kind of ground waiting below. Drop a human into Jupiter's atmosphere, and that whole system becomes useless information. Down is still down, but there is no ground to arrive at. Just more sky, and then something that used to be sky but now behaves like an ocean. Around 60 kilometers below the clouds you see from space, the pressure would already be crushing. Not because Jupiter is trying to kill you specifically. It is simply gas piled on top of more gas for tens of thousands of kilometers, pressing down with a weight your ribcage was never designed to survive. NASA's Galileo probe, launched in 1989, actually tried to measure this. It dropped an instrument package into Jupiter's atmosphere in December 1995, and for about 57 minutes, it radioed back data as it fell. Then, at a depth of roughly 150 kilometers, the pressure and heat destroyed it. It was moving through an atmosphere already 22 times denser than Earth's, and still had thousands of kilometers left to fall. You would not survive nearly that long. Long before the pressure crushed you, your lungs would fail. Jupiter's atmosphere is almost entirely hydrogen and helium, with none of the oxygen your cells depend on. Every breath you tried to take would deliver nothing. Within minutes, maybe less, you would lose consciousness. This is not a slow, cinematic death. It is closer to what happens to a diver who goes too deep without the right equipment. Except the depth here is not measured in meters of water. It is measured in a planet that could swallow more than 1,300 Earths and still have room to spare. Here is where it gets strange though. Even if you were somehow protected, somehow able to keep breathing and keep your body intact, you still would never hit a floor. This is the part that breaks most people's intuition. Keep going deeper, past the clouds, past the layer where lightning bolts 1,000 times more powerful than Earth's crack through storms the size of continents, and the hydrogen gas around you slowly starts behaving differently. Under enough pressure, hydrogen stops acting like a gas and starts acting like a liquid. There is no clear line where one ends and the other begins. You would simply notice, if you could notice anything at that point, that the substance around you had become thicker, heavier, more like swimming through something than falling through it. Keep descending, and it gets even stranger. Deep enough into Jupiter, the pressure becomes so extreme that hydrogen is squeezed into a state scientists call metallic hydrogen. At that point, the hydrogen atoms are packed so tightly that their electrons move freely between them, the same way electrons move in a metal like copper or gold. This is not science fiction. Researchers studying Jupiter's magnetic field, including work built on models from planetary scientist Tristan Guillot, believe this layer of metallic hydrogen is what generates Jupiter's magnetic field. One so powerful, it would be visible from Earth if human eyes could see magnetism the way they see light. That field is roughly 20,000 times stronger than Earth's own. You would never see any of that, of course. You would be gone long before the atmosphere became a metallic ocean. But the physics keeps going even after you cannot. Somewhere near the planet's core, under pressures millions of times greater than what you feel standing on Earth right now, temperatures may reach 24,000 degrees Celsius, hotter than the surface of the sun. Some models, including analysis from the Juno mission team, led by principal investigator Scott Bolton, suggest Jupiter's core is not a hard, defined ball at all, but a fuzzy region where heavy elements are partially dissolved into the surrounding hydrogen instead of sitting in a neat, solid sphere. Jupiter, in other words, might not have a bottom in any sense you would recognize. It just gets denser and denser and hotter all the way down until down stops being a place you could ever reach. So why does any of this matter to you standing on solid ground, reading this on a screen? Because Jupiter is quietly rewriting a rule your brain treats as absolute. You were built by a very specific kind of world. A world with a surface, a world where falling ends. Every instinct you have, every reflex that tenses your body before impact, assumes there is a floor somewhere. Jupiter has none. And thinking about that, even for a moment, forces your mind to hold a concept it was never evolved to hold. A place place that is not empty, not solid, and not anything in between, all at once. Psychologists who study how humans process the unfamiliar have a name for this kind of mental strain. It is related to what cognitive scientist George Lakoff described in his work on how deeply human thought depends on physical metaphors. Ideas like up, down, solid, and falling, borrowed directly from bodies moving through a specific kind of environment. Jupiter breaks the metaphor. There is no up or down that behaves the way your body expects. There is only pressure, increasing forever, in every direction at once. And maybe that is the real reason Jupiter unsettles people more than a planet should. It is not just the size, though at 11 times Earth's diameter, size alone is hard to comprehend. It is that Jupiter refuses to give your mind the one thing it always looks for first: a place to land. Every question you ask about falling into it eventually runs into the same answer. Keep going. There is more. There is always more, denser and hotter, until the concept of arriving anywhere stops making sense. You live your entire life assuming that falling has an ending, a ground, a stop, a moment where gravity's job is finished and the ache in your knees tells you the fall is over. Jupiter has no such mercy and no such ground. Somewhere beneath those orange and white clouds you see in photographs, hydrogen gas is silently becoming liquid, then metal, then something no human has ever touched or ever will. And you, standing here on the one planet in the solar system, generous enough to give you a floor, might never realize how strange, how singular that simple gift of solid ground actually is until you imagine, just for a moment, what it would feel like to fall and never stop.